I've already introduced myself once today, but just in case, I'm Paul Jones, working out of the Grand Rapids office for Configura. I work with the developer training team and also a bit in developer support here and there. So you'll probably hear my name cropping up in a bunch of different places. But for today, I want to talk about child snappers. So child snappers are something that we're going to be pushing out with 12.0. And it's a new way to make, I'm going to say, composition products or composition objects. So in the last couple of years, we've added a couple of new composition objects like the vessel or the component as new ways to build up a product by breaking down into like smaller pieces and putting them together, or another way to represent like a hierarchy of products and put them together. Child snappers are, I mean, while they have lots more applications, that's definitely a role they can fit into. In addition to this, something that makes the child snappers really attractive is the fact that they're snappers. So all of the systems that you're used to working with, all the tools that we already have in CET are going to work with snappers right out the box because we already know how to work with snappers. So simple things like the remover tool already works with snappers. Connectors works with snappers. So everything that you're already familiar with can be carried over to child snappers. So I'll give a quick overview of like the process we go through to make a parent-child relationship. So we have some snapper in the drawing. We'll just call it snapper A. And the real class doesn't matter. It just needs to be a snapper of some kind. We have some other snapper that gets brought into, I'll just say, scope. Maybe this is something that the user is bringing in from the toolbox, or maybe it's something that they're dragging around, or maybe it's just something we're bringing in manually through code. When the user or the code places that second snapper, snapper B, in proximity to snapper A, we'll ask snapper A if it is willing to accept adoption of this new snapper. By default, this is false, meaning that by default, all snappers just work like they always have, but this can be overridden to check this other snapper and return a value of true, indicating that you want to adopt it. And at that point, it's adopted. It is now a child snapper of snapper A. And that's really it. Getting this relationship between snappers, this parent-child or even sub-child or grandchilds, however you want to think of it, is just that easy. At a minimum, you override that accept adoption, and then you've got child snappers. And then if you want to tweak the behavior, if you want to change how a child snapper behaves or what kind of user interactions are allowed on it, you can provide a thing called a snapper relationship. This is just a special object that dictates what you can do with a child snapper on a parent. And that is like all of it, really. That is all that there is to know about working with child snappers. The overall interface for working them is very, very small. It's very minimal code that you need to add to support this, which makes it super attractive as a way to create these composition style products. And of course, it has the added advantage of these just are regular snappers. There's no special subclasses that need to be inherited from or anything like that. Any old snapper can be a parent or a child. So what are these interfaces? So we've got on this guy, we have accept adoption. This is what I was talking about in that fancy animation on the last slide. This is a method on snapper. Whenever another snapper is put in proximity to this one, this method will be invoked, being passed in the we'll call it candidate child snapper. And you just return a value of true or false, indicating whether or not you want to adopt it. And these can perform any checks you like. You can be comparing classes or fields on the classes or whatever you like. If we're talking about a snapper that was already in space, I believe space will even be set at this point. So yeah, you can do whatever checks you like, and if you return to value of true, then the system will take care of everything else. It'll create the family relationship between them, and it will also place the child into the parent's coordinate system, I guess is the way to think of it. I did just see a question come in. How do you prevent circular dependency between parent and child, or even child and grandparent? So the way that the actual relationship between them is maintained is through a new object on Snapper called I think it's family tree. It's a special data structure that just retains your relationship between your parent and all your children. That's not something you need to manage yourself. In fact, I don't think you even can manage that yourself. But it's what maintains a one-directional relationship. Another question, can multiple snappers adopt one child? No, it is a requirement that you only have one direct parent. So if you are looking to set up some kind of a shared behavior between owners, you will have to work out something to handle that. So, all right, so let's say we did accept the adoption of a snapper. What comes next? We have a couple of event methods that we can hook into if we want to do additional stuff upon like a change in ownership. Child added, child removed. These are called when, I mean, the name kind of says it, whenever a child is added to you, whenever you gain a new child, or whenever a child is removed from you for whatever reason. These methods are, these are places where you can maintain any internal state you might need to. So if you need to change any fields, or maybe you're tracking a collection of your children separately or something like that, these might be places where you react to those events happening. And likewise, the child also gets an event whenever its parent changes. Parent changed, whenever your parent changes from 1 to nothing or nothing to something, you get this parent changed event called on you. With at least with the current implementation, and probably this is going to be locked down to this way, you can never change between parents directly. So for example, a child cannot go from parent A to parent B in one step. It'll always go from being on parent A to being put directly into space, and then from being put into space to put on parent B. So if that swap was happening, you'd see this hook fired off twice. Quick question came in. If you transform parent snapper, does it carry all its children? Yes. All of the children are, you can consider them to be in the parent's space in a way. I mean, it's not a space, it's kind of a bad word to use, but it's in the coordinate system of its parent. So if you have a position of 5 feet to the right, then you'll be 5 feet to the right of your parent's origin. Anytime you do things like move or drag or anything like that with a parent, it is going to bring all of its children along with it. In fact, maybe now it is a good time to bring up a couple of key concepts. And I realize I don't have a slide for this, I apologize. So one of the things that makes child snappers a bit unique from a regular snapper, for one, it's not in the BSP. For most, this doesn't mean much. It's a bit of an optimization benefit. There's not a lot of reason for a child snapper to be in the BSP. If you're thinking about things like clicking and selecting, that is still that does still work. You can still select child snappers without them being in the BSP. They also have their own graphics repository entry. And again, we're getting kind of low into the weeds on this one, but for those of you who are familiar with working with, say, components always lump their graphics in with their owner. Child snappers don't have that problem. Child snappers can have their graphics invalidated independently, and they can be cached separately and all that good stuff. They can also be allotted separately. There was a question here, can a child block adoption? I haven't thought about it. I suppose there probably is a way, but knowing the way to do it off the top of my head, I'm not sure. I would have to poke at it a little bit. Maybe if we have time at the end of the session, I can look into that. So once you have this relationship set up, I mean, obviously you're going to want to know like who your parent. Sorry about that. You're going to want to know who your parents are, who your children are, things like that. So we have a couple of helpers for that as well. For example, you can always ask for your parent. This will return your immediate parent if you have one. I say immediate because it's always possible to have, multiple levels of parent-child relationships. Parent will just return your immediate one. Or you also have root parent. This will sort of recurse all the way up through your parentage, returning the snapper that is your, like the outermost owner, the most parent, I guess, the most grandest of parents. You can also ask if a child can ask if it's a parent or if it's a child of some other snapper. The first version being if you're an immediate child, any child of is recursive through multiple parents. And a snapper can always answer the question of whether or not it is a child snapper. I had a couple of questions come in. What happens to child connectors and stretchers? What happens when you stretch a child? I'm going to leave this question unanswered for a second because we're going to talk about that, but I will come back to that. Do child snappers still follow view modes separately from each other or their parent, i.e. a child is visible but its parent is not? I need to double check. We're going to look at something called a snapper relationship later, where we can set up like inheriting of categories and things like that. That's probably the biggest factor, but I think as a general rule, they are considered separately. So we looked at the accept adoption thing, which is largely based on user interaction, like either user bringing in a snapper from the toolbox or dragging one around or whatnot. But of course, it's going to be a common, well, I don't know if it would be a common case, but the case will come up when you want to set up a parent and child relationship through code. And for that, we have this PowerPoint will play along, global function change parent. There's a lot of behind the scenes steps you got to go through and hoops to set up this parent-child relationship. So we have this function here that takes care of everything for you. This is a method that should be invoked on a child snapper. Well, it's a function, so I mean, you could just pass it in as the same argument if you think of it that way. And then you specify the new parent you want to be assigned to, or null if you're looking to be removed from a parent. This will take care of all the steps of creating the family trees if it needs them, calling, add parent, add child, all that stuff. This is also, as much as possible, Core has tried to make it so that all situations where a parent is changing go through this function. And so this also makes it a pretty handy place to debug things if ever you're having to diagnose a problem with child snappers. Tracing some debug code in here should catch just about any case where parentage is changing. And just a quick example of how you might go about setting up a parent-child relationship in code. I called them child snapper and parent snapper. Those are just made up names. It's any snapper. I also have my demo here has them being put into space. That is not a requirement. So for example, if you have, like a factory function or something like that, that is putting together these snappers and setting parents up and all that, that's perfectly fine. It's not required that anything be in space when you're setting up parentage. So maybe, let me think here. Do I have an example I can just drop in? I don't. We'll have to come back to that. At some point, we're going to start looking at, actually, you know what? I'm going to do it now. Now's a good time. I am going to do what every developer should feel scared of doing. I'm going to do a live code example. So what I have here are two pretty simple snappers. I've got this cabinet snapper and a cabinet insert snapper. Doesn't really matter what they are. All they have on them is a local bound and some graphics. So I would like to set these guys up so they can be parent and child. So real quick, I'll just show what they look like. Because, I mean, aesthetics are important, right? Come on. Come on, little guy. There we go. So I'm going to be talking about these guys. Right now, these are two pretty boring snappers. Cabinet thing here, graphics, little insert thing with graphics. That's it. Nothing special is going on. Easy peasy. So I would like to have it so that this guy over here is only available as being a child snapper to this guy here. The user should be able to click this and then put it on the cabinet, and then it creates this parent-child relationship, and that's it. So that part's easy. First, I'll show off my spelling skills. This lonely. Do I know how to spell lonely remove? Lonely remove equals true. Lonely remove does work with the parent-child relationship. So you'll see now this guy is unplaceable. But once I get him as a child snapper, he will actually still work correctly. And that one's pretty easy because the bare minimum for doing child snappers is doing that accept adoption. So let me do that. Okay. So now, in theory, this cabinet should be willing to adopt this cab insert snapper. So let's take a look, see what happens. Again, place out here, can't do it. But if I place it within proximity, it triggers that accept adoption process, and now I can add it. And you can also see that lonely remove does consider your snapper to be non-lonely if it's a child. So now these two guys are parent and child. And we can see that also in the inspector. The inspector has been given a couple special add-ons specifically for working with child snappers. You can see now there's this special section for children. You can open that up. You can see that cab insert snapper is here as a child. And likewise, if I inspect that guy, you can see he has a field item for parent, the cabinet snapper. It's all well and good, but the position doesn't make a lot of sense. Well, you can see how here it just happens to be at wherever I placed it, because that is the position it was at in this guy's coordinate system when I dropped it, when the adoption happened. I can single select, grab him and move stuff. Can even move him away. But it's a little bit weird that there's no help for like where this thing gets positioned, and it's a bit weird that it just kind of stays at that weird position. So got to deal with positioning. So here's one part where the news gets a bit not good or bad, just strange. So for my example, I'm going to use connectors just because we all know connectors, and we'll take the least explaining. However, connectors are an interesting thing when we talk about child and parent snappers, because if you think about it, a connector is it's basically represents a relationship between snappers, or through the proxy of a couple of connectors, it is a relationship to another snapper. So if we already have a relationship, say parent and child, the connector becomes a little bit redundant. It for now is still a handy way to go, because connectors have all of this snapping behavior that we can take advantage of, but is also potentially some overhead. I mean, connectors are just doing a bit more than you actually need. If you want to go the route of, say, snap alternatives, those work pretty well. In fact, in the demo code, these Towers of Hanoi example, these guys are using snap alternatives to do the snapping versus using connectors. And the core team is also, or our internal team is also working on adding in some new ways to position, say, child snappers. I don't want to talk too much about them right now because they're still in active development, but they're going to be pretty slick. Some new tools for handling snapping and aligning of child snappers. But for today, we're just going to whip up some connectors because it works. So I'll do this. This will be insert snap. Actually, I forgot. I did set up a little bit of a cheat here. What do I call the thing? There we go. Okay, just plain old connector. I'll add it to my connectors real quick. Call it insert snap. Cool, so we've got a connector on him. Now we'll real quick add a connector to him as well. Call it the cabinet snap. Cabinet snap. I do not remember what I called it. Cabinet snap pose. Okay, and we'll add it to our connectors. In fact, I'll be lazy and I'll just copy. Everyone I've ever yelled at about copy pasting code is yelling right back at me right now. This is why things go wrong when you copy paste. Just don't do it. Okay. Cool. So Now we have some connectors on these bad boys. Oh, wrong way. Get rid of this. Now they snap. And that accept adoption stuff still is happening. So if we inspect this guy, we'll see that we still have that child. But as of right now, this is basically just snapping two snappers together. Not super exciting. But where it gets a bit more interesting is when we start to control how the user interacts with child snappers. And that's what I will get into next. I did see a question come in real quick. Is this presentation being recorded? And if so, is it going to be available for us to rewatch later? It looks like I did for, did I? Okay, yeah, I did smack the record button. Good. But so either this this very recording will be made available, or we actually did this session in the APAC version of this conference, and that was recorded. So either this one or the version presented by Jonas will be made available to watch again later. Does disconnecting the child automatically remove it from the parent? No. So really connectors have nothing to do with child parent. That was more just an easy way to get these two guys to line up. Is a long-term plan replacing connectors by parent-child snappers and mechanism? No, that's not going away at all. And I hope I didn't misspeak here. Not to imply that connectors are in any way a bad thing, or we're going to deprecate them, or like, you know, turn our nose up at them. Not at all. That's not at all what's happening here. What I meant to convey was that in a child snapper like situation, the parent and the child already have a relationship, so having a connector there is a bit redundant. But yeah, connectors aren't going anywhere. I see another question. Would child get parents' property such as finish color? I'm going to come back to that because we're about to start talking about things like that. So, snapper relationships. The parent snapper is able to provide a special object called a snapper relationship, assigned to a specific child. The snapper relationship object or class is what tells the system how the user should be able to interact with a child. So by the default, you got what you just saw. The user can click on that child snapper. They can single select and drag it away. If that child was selected and it had its own properties, then we would see properties for that child, and so on and so forth. Since the question was asked, sort of, if you select a parent, it does not implicitly add any of the child snapper's properties or vice versa. You could make it do that, but that does not happen automatically. So normally when a snapper is selected, any snapper, whether it be a parent or child or whatever, it will just display its own properties. But maybe we don't even want the child to be selectable. For example, maybe that insert there doesn't have any properties, or it's just not meaningful to let the user click on it and interact with it. So on this snapper relationship, one of the first options we have is method redirect selection to parent. By default, this is returning a value of false, indicating that the child snapper is capable of taking selection by itself. But if it's overridden to return a value of true, it means anytime that a user clicks on this snapper, this child snapper, it should really just select the parent. So actually, I can whip that up real quick just to show an example. First off, I'm going to need a relationship. So we'll go here. We'll do snapper relationship. We'll call this a hidden object relationship. Otherwise return super. Now I'll just go define that real quick. Call this relationships. And oh, no, there's no way I'm going to remember all of those guys, so I'm going to cheat. Always cheat. There we go. So redirect selection to parent. I want it to true. So this is saying whenever the user selects a child, don't actually select the child, select the parent. And we're going to use that relationship for this child. So now I can't even select that insert anymore. It'll always just select the overall cabinet. Maybe selection is fine though. I just don't want the user messing with it, like dragging it around and things like that. I can redirect left drag to parent. What this is doing, it basically says if the user tries to drag this child snapper, don't drag the parent. So this allows you to simulate something like a lot of components, how they work these days. You can have it so that it's still there, it's still selectable and has properties and all that, but you don't really move it, you move this, the parent. And I promise I'm not going to do demos for each one of these. I just want to get the rough idea across. Call it a component like relationship. And we'll drop that in there. So I want to return true. So now this child snapper is going to behave similar to the way most components do. So a component like relationship. So now I can still select this guy. And if he had properties, I'd see his properties. But if I try to drag him, well, I suppose it doesn't mean anything else. In single select, if I try to drag him, it actually just drags the whole thing. I'm going to go through the rest of the interfaces on Snapper relationship, but I hope at least at this point I'm getting across what this is all about. This is changing how the user interacts with your child snappers. So if you do want to simulate like our components work out of the box, you can have a relationship set up to work like that. If you want things to be unselectable or they are selectable or any number of things, that's what this relationship is for. So what other options do we have? Allowing the user to move the child snapper at all. We can even block the user from being able to remove a child from its parent by dragging it away. We can even block allowing the user to delete a child. And we can also affect the interaction with other core systems, such as parts. Should on a get parts call, should the children's parts be included? I believe by default this is on, so child snappers do by default contribute parts. Should the children inherit all of the part tags of its parent? Should the child inherit all of the categories of its parent. And this one, I have to double check on this one. This one was a bit of a controversial one at the time. Basically, do the child snappers exist in the same space volumes as their parent? We had been debating on this one whether or not it should be forced one way or another, so might have to come back to this one. But yeah, I think that's it. So I'm going to come back to some of these questions. So a question was asked, what happens to child connector stretchers? What happens when you stretch a child? Essentially the same thing as if you stretch any other snapper. Child snappers can be stretched. They can even do connecting. The only thing that really changes is that they're going to be doing that all within their own like local coordinate system. So if they're on a parent, they'll be doing it within the coordinate system of their parent. But it all should work just as it has, has in the past. When would a child get parents' property such as finished color? Not by default. So if you did want to do a thing where um, a parent snapper included the properties for all of its child snappers, you would probably want to look into maybe doing prop def exposure, or we're actually working on some stuff with our core properties to make it even easier to just allow additional objects to generate properties. You could do that as well. Real quick, I forgot I wanted to point out something. So in the dev conference extension, which again everyone has, or at least everyone should have access to in Operator, under the spring 2021 extension, there is a section for child snappers. And mostly these are just demos. For example, this Towers of Hanoi example that allows you to, place these guys on here. This is an example of using child snappers and has a custom snapper relationship made for it. It is also using snap alternatives to do all of this snapping. It's not actually using any connectors for this. So you can see a demo of how you might do that. This one is just another theoretical demo. This is a panel frame where these tiles are all actually child snappers. And you can see how by default, I can't actually click on any of them. But if I switch into this special like edit tiles view mode, then suddenly I can click on these and probably display properties for them or stuff like that. So just some examples of different ways you can work with child snappers. Does deleting the parent also delete the child? Yes, it does. In some respects, the children are considered to be part of the parent, so deleting it would delete the children. It might also be worth noting that the children are considered to be part of the parent for the sake of undo. So things that normally trigger undo recording on a snapper for a child, I believe the way it's set up is actually we just record the root parent for undo, which seems a bit strange, but it actually makes it so that overall undo system when working with child snappers is pretty robust and there's not much that can go wrong. Looks way more powerful and robust than connectors. For sure. Especially with like snap alternatives, working with them directly, you can do a lot of things that are a little bit tricky with connectors. Connectors themselves actually generate snap alternatives. But yeah, you can do a lot of really fancy stuff working that way. And the child snapper like pattern, I'm going to say, really does open up a lot of really cool possibilities. I'm really excited to start working with them. But I think that's all that I have planned to speak on. So are there any other questions? So since child snappers are not in the BSP, is there better performance with lots of snappers in a drawing if a lot of snappers are children? In different ways, yes, that is true. By having fewer snappers in the BSP, it makes managing and balancing the BSP a heck of a lot cheaper. Um, and it also has, in certain cases and situations, it also has some benefits for rendering and render culling as well. So yes, that is the biggest motivation, I would say, for this child snappers pattern is getting performance gains out of the BSP. What are the main functional differences between components and child snappers, other than the ability to live free in the drawing? So components are really meant to be a thing on a snapper, or I guess in theory, just a thing on a core object, but really snappers. And even there, they do kind of give away some of their functionality to the snapper that owns them. For example, I talked about graphics. Components do have that get 3D method, but those graphics are still in the end owned by the snapper that owns the component. Um, Components, I guess, if we're splitting hairs, components are a bit smaller in memory than a snapper, although it is probably splitting hairs. It is probably a pretty small difference between the two. We're still kind of in the air about where components are like going to find their home after this, because a lot of the use cases that we've seen for components would really be a lot easier if they were just snappers. There's a lot of code out there, people trying to get components to just behave like snappers. So now that we just have child snappers, what happens with components? And so we're still, debating on that one. Would connect rules prevent adoption? No, they would not. So like I was saying before, there really isn't any kind of a correlation between connectors and parent-child relationships. All the connectors are doing in the example I used was get the child snapper to be positioned in a spot that I like. I really didn't even have to accept those guys as being connected. It was just to position it correctly. It's just a question of like physical proximity. Them being close to each other is what brings adoption, onto the table, and then either accepting or rejecting adoption. Is there any intention for catalogs to insert multiple snappers with the parent-child relationship by default? I cannot say either way. It is, I won't take it off the table. I've heard of some arrangements of products within catalogs that would make sense with this pattern, but I haven't been in that much contact with that team to really say definitively. Any other questions? Make components module objects that contain functionality which can be given to any object instead of putting a method in a superclass. So some classes can have it even though most don't need it. We can just give a class a component we want. Give a class the component we want. So this, I think, is speaking to the design through composition pattern of development where components are these sort of I don't want to say behaviors, but almost behavior-like, where they can just be attached to anything, and they sort of suck up that um, behavior. It is possible that is where components will live. I can't say for certain. It's a bit new, but that would be nice. That would definitely, be a good application for them. ECS. Are you talking about entity component system? that is a bit different. ECS is a very, very low level. That would be like rewriting the runtime style of a change. If a snapper with connectors is a child completely bound by its parent, will this child's connector still work? A snail with connectors is a child completely bound by its parent. Will this child connector still work? I don't see why not. Snapper with connector. Yes, I believe so. What is the child snapper proximity needed? There's a good question. I'm not sure I know off the top of my head. I would guess it's I'd have to go look. I don't know off the top of my head, but I would guess it's pretty generous, on the order of like a meter or two, probably. How close is the enough for the snapper to become a child? Yeah. Oh, bound. Oh, bounds might be a good metric as well. Again, I apologize. I don't know that one off the top of my head, so I could only guess. But checking bounds would also probably make a lot more sense than an arbitrary number. What will happen in existing drawings if parent-child is enabled for snappers already connected? Can this relationship only form by insert or drag animations right now? I believe that is the case. I believe when we actually consider, potentially doing adoption, it's actually in dropped. When we drop a snapper into space is when we check for potential adoption. So snappers that are just sitting there should be fine. That shouldn't like suddenly create these relationships for loaded drawings. Okay, well, I'm gonna, oh, one more question. But could we create these relationships for loaded drawings, like with block snappers becoming parent snappers? That should be pretty easy, I would think. So we do have the ability to create these parent-child relationships through code. That was, if I can find the slide again, that's what we were talking about here, right? Where you can sort of force a parent-child relationship between snappers. In theory, you could, in your load code, I'm thinking maybe loaded one would be the place to do it, create this parent-child relationship.